one of the many, many groups at MIT that works with different fluorescing types of molecules, and this is Professor Bawendi's laboratory at MIT, and he works with quantum dots. And quantum dots are these just very tiny, tiny crystals of semiconductor material. They're on the order of 1 to 10 nanometers. And these can be shined on with UV light. They have a lot of different interesting properties, but one I'll mention is that if you excite them with UV light, they will have some of the electrons move to a higher energy state, and when they drop back down, they actually emit light with wavelength that corresponds with the size of the actual quantum dot. So from what we know so far, we should be able to look at any of these quantum dots, which are depicted as a cartoon here, but here we have an actual picture of the quantum dots suspended in some sort of solution and shown on with UV light, and you can see that you can achieve this whole beautiful range of colors just by modulating the size of the different dots. And we should be able to know if we're looking at a red dot, is a red dot, it's going to have a longer wavelength, so is this a higher or lower frequency? Yeah, and similarly, if someone tells us that their dot is blue shifted, that should automatically in our heads tell us, oh, it's shifted to a higher frequency. And these dots are really interesting in that you can, I'm sure, by looking at this picture, already imagine just a whole slew of different biological or sensing applications that you could think of. For example, if you were trying to study different protein interactions, you could think about labeling them with different colored dots, or there's also a bunch of different fluorescent techniques that you could apply using these dots. Or you could think of in vivo sensing, how useful these could be if you could think of a way to get them into your body without being too toxic, for example. These are all things that the Bawendi group is working on. What they are real experts in is synthesizing many different kinds of these dots, and they have a synthetic scheme that's used by research groups around the world. The Bawendi group also collaborates with people both at different schools and at MIT. One example on some of their biochemistry applications is with another professor at MIT, Alice Ting, and her lab. So really, what I want to point out here is as we get more into describing quantum mechanics, these quantum dots are one really good example where a lot of the properties of quantum mechanics apply directly. So if you're interested, I put the Bawendi Lab research website onto your notes. And also, Professor Bawendi recently did an interview with the Tech. Did anyone see that interview in the paper? So 3 or 4. A few of you read the paper last week. So you can either pick up an old issue, or I put the link on the website too. And that's not just about his research. It's also about some of his memories as a student and advice to all of you. So it's interesting to read and get to know some of these professors at MIT a little bit better.